Okay, sorry, it's a bit, maybe just a bit lower. Thank you. Well, thank you very much. You know, it was good afternoon. It it sounded like a boxing match at this stage. So thank you for the introduction, and I really appreciate and to all the organizers, Prof. Dion. Thank you very much for also for inviting me to speak about this. So we are really fortunate, you know, on the one side we applied for the ISO certification, 13485, and yes, on the left side you can see the certificate being issued. That was around 2 months ago, and today I will spend some time just briefly how this whole certification process links up with each other and how it is benefiting the patients. So my talk will be, and I will try to make up some time. So if you have questions afterwards, please feel free to come and ask me. So why is certification? And then more on the 13485 certification, the quality management system, how our quality management system is basically working, the design process, orthopedic implants, custom design implants. I will show you where we use this quality management system and why it is so important. So how is additive manufacturing improving quality of life locally? So I will warn you before I put some sensitive slides, so sorry. This one was maybe a little bit too late. So this is a video clip that I just wanted to play to you. Maybe I must play it before. Before I Okay, let's try it again, maybe.
Live a normal life again. I never thought I would.
Okay, let me just quickly, can I quickly just go back, yeah? Okay.
And at one point I could barely breathe, but I must say, after the operation, I feel a young man again. I'm happy. I can live a normal life again. I never thought I would.
Okay, so on the one side, the top gentleman, they had to remove his whole mid face due to cancer. And you can see the doctors putting in normal implants. We had to manufacture a custom design titanium implant with a denture, a clip-on face that the Dr. Kielers van den Heever manufactured. And then the bottom gentleman from Springbok, he's a state patient, and he had cancer in half of his jaw, and that was replaced in 2012. So since 2013, we assisted, you know, it's more than 30, it's maybe now 40, around 40, maybe 45 patients, a lot pre-operative planning models. You can see shooting accidents, cancer. Then we're also manufacturing a positioning guide system for ear prosthesis, where they want to drill into the skull, and that was now developed over three years also, going into a few surgeries. This is where we started, and I will show you some of the newest examples. Implants, you can see a lot in cancer, you know, where cancer is destroying half the jaw, bottom jaw, top jaw. This was a total, a full mid-face implant. So if you Google additive manufacturing certification, I think if you Googled this 5 years ago and you can ask Terry, you won't find so much. But now there's a big drive for certification. If you want flying parts or you want implants, you must have a certified process. The process that can show you repeatability, consistency, things like that. That is the questions. So you will find like FAA perspective on additive manufacturing, even development certification of additive manufacturing materials for human rated launch vehicles in space manufacturing. Very interesting document by the FDA. It was a draft document. I think you can see here, date issued in May 2016, and we also went through it and see how it matched up, and I'm really glad to say that we are answering most of the questions that they are putting forward. But you will find more and more companies, like this company I think was also in March this year. I don't know if it's true, but it's, you know, they say the first 3D printing company to receive ISO 13485 certification for 3D printed medical devices, more for drilling guides, things like that. And then I think those of you that really follow the additive manufacturing, this was implanted in Spain, and it's courtesy of Cyro, and I have a short video about this process that I also want to show you.
CSR, in conjunction with Anatomics, has developed a sternum implant for a patient suffering from cancer. It involved a very complex, world-first procedure. Anatomics contacted CSIRO. We have access to an electron beam metal printer, which means it's a really high-quality implant. And we also have the experience of having done these types of jobs before. So 3D printing works by inputting a 3D digital CAD file into a computer, and then that computer talks to the machine. The machine puts down layer upon layer of material, and each layer is fused. So as each layer is fused, you then start to build up a product as your layers increase. And Anatomics and the surgeon worked together quite closely. The way that they came up with the design was to have these pieces that went over the bone, and then you could screw through the bone, so it's attached really securely. The reason that 3D printing was designed for making this implant was because it needed to be customised exactly to suit the patient. No human body is the same, so therefore every implant is going to be different. So this is the sternum here. This here is mimicking the rib cage, and these pieces here are what attach onto the ends of the bone. To get to this implant design, Anatomics used the patient's scan data, and that meant that they were able to make an implant design that exactly matched the patient's anatomy. It would be an incredibly complex piece to manufacture traditionally, and in fact, almost impossible. Australia has a really fabulous skills base in biotech and biomedical manufacturing. 3D printing is set to really take advantage of that skills base. Internationally, we're now becoming very well known for our expertise in 3D printing for biomedical applications.
So I had the privilege of meeting Alex at Terry Willis' conference last year. So we are taking notes, but it's very, very impressive work that they are doing as well. Also, just a courtesy slide of Gideon Levy. If you have a look at really the quality management system for production, it can be, even you need to have a look at equipment, your feedstock, how do you handle your material, the virgin material coming in, also the refreshing of the material, the sieving, all of that. The thermal processing, and I think we mentioned it, we don't have a heaping plant in South Africa, and I think that is something that we will need long-term maybe to discuss. I know Prof. Dion will start writing a funding proposal. No, I'm just smiling. So a stress-relieving cycle, but also, keeping track. I think traceability is very important. You need to know exactly if an implant goes in, and in 2, 3 years, 4 years time it's coming out, you must know exactly what was the batch material, even the surgical guides that was used in what lots that polyamide basically powder was coming from. More busy slide, and you will see a lot of busy slides today, but I think what's very important is their standards, and we mentioned that the ASTM, the ISO standard committee, are working together to have a look. They started off with just general standard, and then you can see here it's 3 levels: general, top level additive manufacturing category, some more, and now they're getting more to the lower. And thank you very much, Marius Vermeulen. I don't know if he's here, but for this slide. So because even in metal, you will have maybe, you know, you would like to have a medical focused standard if you can, and maybe an aerospace, because even in the same machine, the same technology, powder bed, titanium, it would be nice to have maybe a application type of standard. These are the standards that we are using for our quality management system, and you could see a lot of ASTM standards, but as well as ISO. I'm not going to go into detail, but that you can also just see, you know, we are referring back to these documents. So we're not just writing our own policies and procedures, but I think it's important to always use them as reference. I think I'm going to skip this slide because just due to the time, but please go and Google ASTM. I have very nice videos now about why these standards are important for 3D printing, and you could go and have a look at this video. So coming back to our DMLS of titanium, and again, I think what is credit is due is Prof. Dion de Beer. He was still part of us, I think already in 2006. He saw that titanium could be an area, you know, for future applications, and I think that the THRIP application was quite good at that stage to 2007. We acquired the beta testing machine from EOS, and then from there the research started. 2012 we traded in the machine, and we have now currently 2 metal systems with us. A lot of optimization for medical application. That's not even other applications, just focused on medical. Like I mentioned, 3 years ago we started with the certification, and now, yeah, so we still, the timeline, you know, I think 2016, so we're still on target. And then this slide is, I think already maybe 4 or 5 years old. So we received the certification. I think what's very important is it's a quality management system granted after a rigorous audit. The audit was done by TV Rhineland from Germany. And this means that a product produced at the center conforms to international standards and accreditation. I think what's important for us is it's opening up for us maybe doors internationally as well. That we can, say for instance, produce implants, custom design, but also maybe production parts later. And I can discuss that, you know, how do you get the CE mark for this, but there's a big clinical evaluation that also need to follow. Okay, just on how our certification framework is looking like. So you will have a prosthesis request, then file verification. So a lot of standard operating procedures had to be written for each step, data preparation, all of that, to verify that it, you know, the quality is good going into the machine. We have standard basically monitoring. There's monitoring software. You can see there's a copy from EOS. We are logging the oxygen online laser control. But you go through all these checks. So if everything is good on this side, you go to the stress relieving, part removal, support removal. That's where the extra few days are coming. As well as then we do density checks, heat treatment to improve ductility, and that's why it's so long. You can see many steps. Even so, with all the implants, we are manufacturing destructive components as well that we're sending at this stage. It's still outsourced, but we purchase our own tensile tester that we can do it in-house. We need, as grown, the ductility of the implants is around 2 to 5%, and we need to improve it or get it up to above 10%. That's plus minus from 8 to 10%. So a lot of, you know, post-processing is just polishing, non-destructive testing. So that's done at Stellenbosch University with their micro and nano CT scanner. Final cleaning, sterilization of prosthesis. That is also done outside at EPRO at this stage. But you can see this is the non-destructive testing that we're currently doing also to create the history. You know, if we're doing now 100 implants, that we can say, you know, what's the trend? We need to, with this ISO system, also plot statistics, you know, accuracy, the strength of the implants over time. And you could see here's just a, you know, just a tensile test. So then from there, it's basically labeled and then it goes off to the hospital. So currently, this is how the system is looking like. So there's Standards Act information. All the standards are copied in there. All the acts, the Medical Device Directive, then a lot of policies. How is our policies looking like? I know people from a university want to move away from policies, but there's a lot of policies, procedures, all the flow diagrams, the forms that you use. If you change a form, you need to fill in another form to change the form. Because so it is, and you can ask Jenny that's sitting there, she's our ISO administrator. The manufacturing manual, I think, is the Bible of this whole, how do we manufacture and what is crucial. But human resources, process validation is also a very important fact. I will show you a slide about that. But yes, so everything runs from this one index, and it's linked. And I must, Andre ten Apel, he's not here today, but he helped us to put this whole system together, TNMC medical device. Currently 6,088 files. The beginning of the year it was around 4,000, so it's going quite fast. I'm gonna try to move as quickly as possible. Well, I see already used 14 minutes, so it's going. But if you have a look at policies, procedures, so even how your business is structured, I think that's important. They want to see governance, you know, is it a stable environment, or will if somebody leave, you know, what's the risk from that side. But all the procedure for product development, marketing, sales, I'm not going to go into so much detail, but I think what's very important is procedures for validation. How do you validate? So on the one side you have a standard operating procedure. Then from there, how do you validate if this is working, you know, constantly? So a procedure for product development looks something like this, and you will see there's unfortunately a few people that need to sign off on all of this, and I think they are the first guys that they come if something goes wrong. So, but even the management representative, the ISO administrator, and then we have a local representative also. Just on the manufacturing manual that I was talking about, the Bible, I think it's very important, you know, there's also general areas. So how is your cleaning of your facility looking like, manufacturing cleaning? How is the quoting and invoicing system works? What is the implant manufacturing process flow? The guides that we are manufacturing, the cutting guides, drill guides, all of that. How is the process flow? Even, you know, and then we start off like with a process overview, just looking at all the steps as I showed you. But with each picture that you put in this, you know, you need to describe and link them. But you can see equipment maintenance, calibration, all of that needs to be logged. I think that's very important. You need to show also what is the state of your equipment. Is it being maintained? And then, yeah, the process continue. I'm not going to go into, so we split it in metal for all the implants, and then the plastic for all the cutting guides. Again, this is how a standard operating procedure looks like. You need to, even if you do stress relieving, you need to exactly show them, and you can't deviate. So last year we had 2 degrees deviation from what the standard said, and then we had to change the whole document. And it was just something, you know, that we picked up before the audit. So audit. So I think that's very important. The documents must speak to each other. Otherwise, the guys will pick it up quickly. So, from a management side, this is called the process ownership matrix. So for each step, you will have, like say for instance, marketing. So who's the process owner? And then also who's the guy that's going to check him. So at this stage, you will see like our project engineer operations, he's taking care of this process. But even these steps, what is the key performance areas, the frequency, the actual, and where's the records lying, you know, the actual proof of this. And there's many, I think there's just 8, but you can have a look. There's marketing, sales, customer satisfaction. So on the one side, every 3 months we need to get feedback from customers. And then on the validation side, I think this is a very important thing. We thought when we started, if you write SOPs, so the standard operating procedures, we thought we are there 80% of the way. And then they said, yeah, but you need policies and you need this. And at the end, we had to develop. We're still busy with the sterilization validation because that is now outsourced at this stage. It's not something, we don't have a clean room currently with us. But the design process, what's called the IQ, the installation qualification of the machine, the operational qualification, how all these SOPs links with each other, and then the performance over time. Just going to quickly, you know, this is typically an EOS. I'm not sure if Joseph is here from EOS already. Did he arrive? Yes, there at the back. So EOS, and thank you very much for all your help. You know, they assisted us, but you can see the IQ is very important. So even like the Z-axis, if you tell it that it needs to go down 30 micron, you need to prove that it's going down 30 micron at 100 steps, and it's consistent. Otherwise, you know, so there's a lot of checks. Same with the laser power, so that was from the IQ side. I think from the, you know, this is the operation qualification. So here you need to write, so for implant design, you have a document that go in, you know, so there's a lot of different documents. But this is to say, all these work instructions, how do they work together? And that's being evaluated. Last few slides about the process itself. This is the performance qualification. So we had to do, this is the part that as soon as the machine is installed, when it was installed in 2012, we did a part like this, and we did another one, I think now in 2016, and we plot the accuracy of the machine. The consistency also, like tensile pieces, that's all over the platform. Also to prove that the UTS of all these test pieces are throughout, and then repeatable between builds. So I think that's quite important, not to go into too much detail. What was quite interesting for us is we had to validate software that was already ISO certified. If you have a look at materialized software, so we are using all their software, but we had to prove that on the one side, if you do like the mimics translation, you know, going from the CT to MRI scan, that at the end, if it's a 1 millimeter, you need to end up with 1 millimeter through the design process, through the slice software, up to through the machine. And so we had to write a whole document for this as well. So this was quite a process, but we could prove it with actual results, you know, taking a known model through the CT scan process up to end. And I think that was quite interesting. Just records, many records, you know, and how long you need to keep them. 10 years, I think lifetime plus 5 years. So just on the design process, so all the legs, if we're getting a design from the outside, how do we review it? For manufacturability, how do we assess? Also, if we have like Dr. George Vikatos, Professor George Vikatos, he's sitting on that side from UCT, even if he sends us a design file, we have a design review, design verification, and then validation. The validation from our side is from the surgeon, you know, how's the information coming back. Design input from the doctors, you know, exactly what screws do they want to put in, what is the concept looking like. They need to sign off. Yes, and then the final design at the end. So you can see here. So continual improvement on the system. So I think what's important, we're doing a product risk assessment, a financial risk assessment constantly. You know, does it change? You can see this. This is now product risk assessment, structural failure, design out with intolerance, ineffective operational planning model, infection. You know, all that. How do you manage that? If you give it clean to the hospital, there's sometimes the liability must move over. As soon as this is quite high, you must put in measures in place how to mitigate. You know, what are you gonna put in place that you can get from red to maybe yellow or green? And then also, Gerry beside note, I think Prof. Andre van der Merwe is also here. You know, we are working with Stellenbosch University with industrial engineering, also to help us to each step have risks. And how do you can see that's internal risks and external risk, and each of these steps have a different weight. And how do you manage that? And where's the critical areas? So you can see this is risk of manufacturing poor quality, customized facial implant. But I think what's important also, there's for when your cost is getting too high. You know, with the exchange rate, that's a risk for us at this stage. So more to the other things. So now I need to say, so for the not yet, the sensitive viewers. So yes, I think what was for us a breakthrough is the doctors working with us that pull us, you know, all the way. So we started off with non-load bearing components, maybe like an orbital floor or something like that. And this was the first South African 3D printed implant manufactured here. And you saw the movie clip from this. He's now maybe, I think 34 years old. He's doing very well. It was over designed. You can see, I think you can pull your car with that design in titanium, but we only had around 2 weeks to do this, and we learned quite a lot. If you have a look at our next case, this was a lady, she was operated on October last year, quite a big size, I think almost like your first tumor, and it's not a cancer tumor, it's a benign tumor, but the problem is if this tumor is continue growing, it will close her airway. And you can see this is the process flow. So we received the CT MRI scan data. From there we did the conversion. We actually manufactured the pre-op model that we sent to the doctor. Remember, Kimberley Hospital, this was also done as a small center in South Africa, or a small hospital. And if you can give anything that to these doctors to help them, you can see they indicated also where they want to cut. I think this model is maybe at our stand. I don't know if it arrived yet, but you can see that's the frame. So we went from a solid to a frame because this patient is currently, they harvested some of her hip bone that was implanted here around 3 months ago, and we hope for bone, you know, a continuous bone regrowth in this area. So, sorry, yeah, maybe I must just go, yeah, just one back. So sorry for the, but this is now out of the, this is out of the theater. You could just see, this is the actual cutting guide, you know, laser center cutting guide, and it fit perfectly. You can see this guy is almost fainting now. But just to see the fitment afterwards, you know, and how much time it saved for the doctor. So we're also manufacturing a sizer out of nylon before they open up the titanium implant, just to make sure, does it go in, does it go in. If the bone is good, then from there they will open up the sterile package. So another case that we did, also here from Pretoria, last year. You could see also mid-face. This was quite a big operation. Was still a lot of swelling, but they had to do a forearm flap remove some of the forearm with blood supply to make a separation between the oral and nasal cavity. Cutting guide again, and that was the titanium implant. Just to show you how we start trying to, because I think if you talk to the CEO from Materialize, he will tell you we need to create now the clinical benefits must be documented. You know, it's not just always just cheaper or whatever, but long-term recovery time. If we can save time with a cutting guide and the patient is maybe 3 hours less in theater, the recovery time is quicker. So we're trying to bench what is the conventional treatment and on the one side the additive manufacturing. You could see here, so conventionally the golden standard is still what they call a fibular flap procedure that they remove from the bone, from the leg, just your fibular bone. But the thing is, in South Africa, that's difficult. There's not so many big centers that can do those surgeries for the blood supply and to make sure. So we need to look at maybe an alternative. Here you can see 9 hours theater time. This can be done in around 6 hours. Also, here you need ICU, and you need around 7 to 10 days hospital stay. And with this, that one patient that we did open her mouth already the next morning. You know, she could move. So that was quite good. Orthopedic implants. This was a project that was done for Allegra Orthopedics in Australia. Also implants for amputees to attach prosthetic leg. And here you could see the final machine components that was shipped with a lot of lattice structures for bone regrowth on the side. Also working with George, I borrowed one of his slides. I think he will show you maybe more on Friday. But we got it right now to have a pre-machined titanium and only manufacture the lattice structure in a powder bed system on top, and you know, the bond between the lattice structure and the pre-machined part is quite good, very good. So I think because on the one side you think you will always grow everything, but I think on the other side is we saw sometimes the combination between machine components as well as with what we can actually build can make a huge contribution. This was a pelvic implant, also done by Atri, Dr. George Vicatos, and you can see the very fine structures, and that was quite a huge implant that went in. So for me, yeah, I think I need to wrap up. There's a few other projects that we are busy with, and I think on the one side we will always have a look at custom design implants, but you need to keep the machines full. And from a business side, I think it's important to identify other projects, like these heart valves that we are developing with the University of the Free State and TIA. You know that we additive manufacturing these heart valve frames. Our biggest challenge now is just the final polishing to get it quite smooth. We proved that we could do around 50 of them at a time in the machine. And then furthermore, we're doing also a polymer heart valve development. So Leps Mashani, he's going to do a full presentation on this project. But we basically additive manufactured the frames as well as the molds. They were polished with at First Technologies in France. Is it the same as Best in Class in the US? I think it's the same company. But if you have a look, and I want to show you this, these are now actually the parts being manufactured in the machine. But this is the heart valve on the test bench. And these are additive manufactured components. And you could see, you know, so it's now going through fatigue cycles. So with a pressure, and you'll see now from the top. This is quite nice. It's bending the pillars. The heart valve is there's still some work. It's not closing properly. It will never close, it seems like, on the sides there. But yeah, just to prove, the durability of this. External prosthesis, I think what's important, I have 4 minutes left, so I need to, we are using also, as part of the ISO, you can't say I exclude this, or I, only have a look at this machine, or, close down. I would love to do that, half of the center. So all the machines running there, even if we do the nylon models, they need to be done in this way. So this was a small foundation. This girl lost her ear due to fire. The small foundation helped, and you could see, please go and have a look. There's a lot of testimonials from the little ones, that helping. That's Dr. Kielers van der Heever, and yeah, she's doing very well at this stage. Also training, I think it's important. So this was a training session how to sculpt a nose. So I'm not a very good artist, but I'm trying. But you could see a lot of postgrad students going through this training. Other applications, this was the biggest part that we manufactured in the powder bed. It was a test component for the CSR as well as Airbus, and it's humongous. You could see the base. I think Gerry was mentioning about the screws. The guys came to call me because they were afraid to strip the one bolt. So that's a 50mm base, titanium substrate. And so you can just think that was maybe around 280mm high, but the walls were quite thick for them to be able to cut test coupons. And I almost stripped the one Allen cap because it's bending that thick plate. Also, Charmaine Johnson, she's sitting here in front, and thank you very much for this picture. But we are using also the metal for wind tunnel models, and you can see sacrificial or destructive testing components that we're manufacturing. And I think this is a nice project that we will continue in the future. Even titanium trophies. Maybe my colleagues from the National Laser Center, that was welded. And you can see the final ones. It was done in 2 pieces just due to the amount of time that we had to manufacture all these trophies. I think what's very important for us is, I need to congratulate, it's a team. It's not a one-man effort. And you can see we are quite a small team. We are really a small team. And I think, I'm looking forward to the future. But, to work as a team and everybody that put in, long extra hours. So I must really thank all of them. So the new cases, now you can see the warning. So for this is what we are ending up. This is a patient also mid-face. This is the clip-on face area. Torsten, I know these pictures are, you also don't like the blood pictures. But on the one side, we have also a rhino project. This poor rhino is we are now in this next week or 2, we will need to make a titanium plate. But I was thinking more not to manufacture it fully using 3D printing, but maybe to manufacture the tools and then press it standard plate, in the shape for this rhino. Another patient in Kimberley, mid-face, and then this boy, he was born with Treacher-Collins syndrome, without ears, and they did place cochlear, so we're gonna manufacture for him then also ear prosthesis. So I think for the future, I think what's important is upscaling production of additive manufacturing. I think that's very important. That's now the next step for us. Create national awareness of what's the clinical benefits. Focus on training. I think there's a lot of, we need to get, and we're trying from our side, to get young people exposed, especially in the medical side as well, but also to do short courses, things like that maybe. So we're thinking of a summer school for all the European people in January. So here Bloemfontein, in South Africa. And I think we will continue improving quality of life. There's a lot of acknowledgements, and I think I will need a separate page sometime soon. But you can have a look. Also, my supervisor, so I need to finish a PhD, so thank you very much for them. but you could see, you know, Department of Science and Technology, National Research Foundation, materialized sponsored last year for us a little bit of funding for some of these cases, state patients. Technology Innovation Agency, you could see, maybe I'm missing one or two. And I think our new partners, so we received now from the Emily Fuchs Foundation, you know, the Fuchsware, the appliances that was developed many years ago, maybe for the people that's maybe a little bit older, I can still remember that. So the founding, the husband and wife, they started a foundation, and this foundation is in South Africa, so we received now 4-year funding to help these state patients. I think it's a big challenge for us in our country. The state hospitals, you know, they are cancelling theatre time, and especially with reconstruction work, they will remove the cancer and then they will leave that patient. So at the end, you know, this is the reality that we need to work with. So we're trying with them, Technimo, Titamed, R3, and then we are at this stage negotiating with a hospital group. Or maybe next year I could put a name. So thank you very much.